Right, types of errors. This is my table for the type of error. So we've spoken about a type 1 error. A type 1 error is when H0 is true, and if H0 is true, we should accept it, but we don't. All right, so H1 is true and we reject it. It's essentially the significance level. All right. So we've got our rare bird sightings, just like the frogs, mean of 3.2, 4-week period. This is like a toy example, basically the same one as the frog example. All right, just an absolute toy one. I think it's even the same numbers, isn't it? 3.2, 12.8, right? Exactly the same. So we've done part 1, part 2, part 3. Okay. So see previous slide. All right, we've already done this with the rare birds. Although I think we did it with rare frogs. You did frogs with birds. Oh, days away now. So it really is type 1 error is basically your significance level. It's the area of the critical region. All right, super easy. The probability of rejecting H0 when you shouldn't, i.e. H0 is true, and we just happen to land in the rejection area, i.e. it's the area of the critical region. Now, a type 2 is the other way round, is H0 is not true, and we accept it. Oh, can we just go check our critical region, actually? What did we say it was? Yada, yada, yada. Wasn't that one? Was it this one? No. There we go, rare birds. Oh, it is the exact same one. So we said 5 or less or 21 or less, correct? So less than or equal to 5, more than or equal to 21. Right, so my critical region was less than or equal to 5 or more than or equal to 21. Okay? So when are we going to accept? We will accept or like not reject. I hate this terminology, but it's easier. We will accept H0 if X is between 6 and 20. We will accept X if X is between 6 and 20. That is when we will accept H0 or not reject it, rather. See my relationship example. Okay, so you will not reject H0 if X is between 6 and 20. Okay, we've got all the sketches over here. Okay, so if you're between 6 and 20, we reckon all is legit and we are not going to reject it. But here's the thing. What if H0 isn't true? What if, in fact, it wasn't 2.8, whatever it was, 2.8, it was 2? Well, let's see. If X is therefore, and remember, this is per 1 week, we're doing it over 4 weeks. So if X, in fact, has a Poisson 8, what is the probability of me accidentally accepting it, right? What is the probability of me accepting if Poisson, if in fact it wasn't 12.8 and it was 8? So we're going to go here. We can go statistics. Let's go distribution. I've been enjoying the distribution area. We want to be in between two values. We want to be between 6 and 20. And lambda is 8. So 0.8086. So in fact, if the actual average number of sightings was 8, or per week was 2, so for 4 weeks was 8, there is an 81% chance, right? There is an 81% chance of me accidentally accepting or accidentally not rejecting H0. And if the number of birds was actually 5, or sightings per week was 5, then we're looking at a Poisson for 4 weeks of 20. And the probability of making a type 2 error, i.e. not rejecting, goes up here. Can I change the lambda here? No, I have to go back here, do I? Lambda is now 20. Is 0.559. All right, roughly 56%. Now, this is my last slide. So there is no single probability of a type 2 error. So this is very important. With this hypothesis test, there is a probability, a singular probability of a type 1 error, and we pointed it out when we did it previously. It was over here, 3.4%, 3.4% probability of a type 1 error. The probability of a type 2 error depends on what the actual parameter. Yes, I've just seen that. All right, there is an actual parameter. So that will depend massively. So the probability of a type 2 error depends on what we think the actual lambda p mu actually is. All right, so here I've got different types of things.